Hey everyone, welcome to another video. Now we are looking now at some similar things that we have talked about in previous years, particularly as it relates to probability, but we explored these ideas but never really gave them a name or looked too deeply in what these things mean. Now, we are talking today about dependent and independent events when it comes to probability. Now, this video is going to be quite a bit of talking, so if this doesn't interest you, you can fast forward to where we work through a couple of examples, but a lot of the content from here is less calculation and more conceptual, more understanding, okay, what do we mean by a dependent event or an independent event? What makes this that type of event? So I'm going to throw a couple of scenarios your way. Now, something like a coin flip. We introduced this idea when we first started talking about probability. Now, we said that you flip a coin and one of two things can happen. You can get a head or you can get a tail. And we said, okay, there's one half. Both getting a head or a tail, there's a probability of one half. Now, we also said here that, okay, we flip a coin and say we did this one more time. We flip this coin, we get a head, we get a tail. So we have our first flip here. And we have our second flip. Okay, so when I get tails, I can get heads or tails. And once again, we said, okay, cool. We have a half, we have a half, we have a half, and we have a half here. Now, zooming out and looking at this little probability tree that we've drawn here. We looked at these in previous videos. But having a think about this, after the first coin flip, does the head we got, for example, here, affect the probabilities or affect any of the other events? Is there anything that changes? Does flipping a head have any bearing on the second coin toss? Well, actually doesn't, because these are what we call independent events, and the probabilities do not change. So my first flip has no bearing on the second flip because my probabilities are still the same. My probability here of getting a tail has no bearing on these two here. So we define independent events. Let's just zoom in a tad. Okay. We define independent events as if the outcome of the first step, so for example this first toss of the coin, does not change the probability of the second step. So, that is how we can define this idea of an independent event. So one does not affect the other. One has no effect on another. Now, a famous idea from this idea of independent events, for example, is what we call the gambler's fallacy. So probability, unfortunately, has a lot of carryover to the idea of gambling, betting, and betting on outcomes and things like that. Now, what the gambler's fallacy is that picture you have a roulette wheel. If any of you have been in a casino or seen this in movies, you have some red things here, some red options. You essentially roll a ball onto this circle, and you're either going to land on red or black. So you have black here, black here. Obviously this isn't really what it looks like, but this gives you a rough idea of you're going to roll and you're going to fall on some type of thing. Now, on some color. Now, what the gambler's fallacy is that people say, okay, well, it's been red like 4 times in a row. So say we had, 4 reds in a row. Now, if you get 4 reds in a row, the gambler's fallacy will tell you, okay, it's bound to be a black now. Any minute now, it's going to be a black. But this actually has no real, because these are independent events, there is no real logic to this, because your bearing, your 4 reds that you've rolled have no bearing on the black. It's not like once we roll a red, one of our things is going to disappear, giving us an opportunity for more blacks, or when we roll the other one, we have more blacks or more blacks. The number of these red portions here never changes. So we're always looking for the same, we're always measuring the same sample space. So getting a red on here has no bearing on whether you'll get a black. Why? Because the sample space doesn't change, and you're always going to be rolling one or the other on the same roulette wheel. Now, you may notice I talked about sample space quite a bit. Now, with these multi-stage events, for multi-stage events, so when more than one thing happens, that's why I use a roulette wheel analogy. For multi-stage events, so something like a roulette wheel, that is an example of a probability with replacement. Remember, we talked about these last year. So if I get a red here, it's not that the red gets discounted for the next time. I can still roll that same number. So it gets replaced. So I record my roll, and then it gets replaced again. So multi-stage events, so those with replacement successive events, so those happening one after another, are independent. Now, let's talk about dependent events. And there's already a hint here as to what we may be thinking of. Now, consider dependent events. Let's go back to a question we did a while back, which was you had a bag of, let's say, blue and red balls. Okay, now we modeled this using a probability tree. When we looked at this, for example, we said, okay, the probability of getting these blue ones is going to be 3 over 5, because I have 3 balls out of a total 5 that are in the bag here. And 2 out of those 5 are going to be red. Now let's say I pull out one of these blue ones. Will the probability change? Now I'm going to pull out one of these, but without replacing it. I'm going to pull out a blue one without replacing it. So I'm going to take this one down here and I'm going to pull it out. So let's leave it way down here. So how do my probabilities change? Well, I have a smaller sample space because I have 4 balls remaining, and now 2 of those are going to be blue. And down the bottom here, I have 2 reds out of a possible 4. So my probabilities here are changing a little bit. Let's consider down here. Let's say I pulled out a red one first. Down here. My probabilities change because now I have 1 red. Because this isn't being replaced, I have 1 red out of a total 4. And my blue, I have 3 out of a total of 4. So let's put this back in. If I think of these as my first ball and my second ball, the effect of not replacing this means that the probabilities change. These are different, as well as these ones. So one probability affects the other. So the probabilities on this second ball are dependent because they depend on what we selected for the first one. So therefore, we can say that, let's do it in a different color, for multi-stage events, where there is no replacement, or where we're looking at without replacement, successive events, so one happening after another, are not independent. Or in other words, they are dependent. One particular thing one outcome affects the probabilities of the other. So this is how we can distinguish dependent and independent events. Now we're just going to do 2 practice questions, just classification questions. Like I said, this is a conceptual topic. It's more about not so much calculating, but deciding whether events are dependent or independent. Now, let's consider 2 events, A and B. So, the event A is rolling a 6 on a die. And B is going to be rolling a 3 on a second roll. Okay, now imagine rolling 2 dice, or a pair of dice, or just rolling 1 2 times. Now, say you got your, say you rolled a 6 here. So you roll 6 on the first roll. What happens in the next probability? So you roll a die, you record a 6, you reset it, you roll another die, or you roll the die again. There's no impact that event A has on event B, because the probability of event A, the probability of rolling a 6 is going to be 1 out of the 6 here. But if I were to roll this again to get a 3, it's not like the 6 disappears, it's still an option. So the probability of rolling a 3 is still going to be 1 out of a possible 6 options. So here, the probabilities don't change. Don't change. So these are independent events. Rolling a 6 and then rolling a 3 after, just rolling a die twice, one outcome does not affect the other. Rolling a 6 here did not affect you rolling a 3. You had the same probabilities, nothing was changed. One had no impact on the other. And finally, question 2, we have 2 playing cards are randomly selected from a standard deck without replacement. So we have 2 cards drawn from deck without replacement. What does that mean again? Well, without replacement just means I pull a card out, I don't put it back in, I don't replace it. Now, let's do this slowly. So the first card, we'll call this card A. Let's say this is a the first card is a heart. So doesn't matter what type of card it is, but we know that the suit is a heart. And the second card, B, the second card is also a heart. Okay. Now just picture a deck of cards. We have 52 cards. So we have 52 lots of cards. Okay, I pull one out. I pull out card A. I'm left with, so we'll go after pulling card A. After pulling card A out and not replacing it, how many cards am I left with? Well, I have 51 cards remaining. So therefore, by not replacing this, my first heart that I drew has an effect on the second one I draw, because that means that there's going to be one less heart to choose from. And we don't even have to think about how many hearts there are in a deck, but I pull one out. I pulled one out of a possible 52. My probability is going to change if I don't replace the card, because first of all, I have one less card to choose from, and I also have one less heart to choose from. So therefore, my first outcome, pulling the first heart, does have an effect on the other outcome, because I have one less card to choose from and I have one less heart to choose from. These events, therefore, are not independent, or in other words, they are dependent. But that brings us to the end of the video. If you stuck through the whole thing, thank you so much. I know it was quite conceptual and wordy, but that's what this topic is all about. It is about understanding the impact of one event on another, and then how we can define these types of events. And we do this by saying an independent event, so one in which one thing doesn't affect the other, or not an independent event, or a dependent event where one thing does actually affect the other. But that brings us to the end of the video. Thank you so much for joining me, and I will see you in the next one.